All right, so welcome to class, everyone. I hope we are good. In the last class, we looked at refraction, right, on plane surfaces. So today we're looking at refraction through lenses. Our focus today is on lenses. I'm glad we've treated some things on, what do you call it? We've done things on curved mirrors, right? The same concept, but for curved mirrors, you saw what happened here. We had the convex mirror and the concave mirror, right? And just yesterday, we looked at refraction. What does refraction entails? We looked at the laws of refraction. We looked at some of those key things we solved yesterday in terms of the refractive index. We looked at minimum deviation when you are looking at your triangular prism. So all of those things are, are key things we looked at, even deviation, right? So now that now introduces us to the next topic, which is refraction through lenses, right? So now, what are we going to look at in today's class? So first of all, we're going to look at the types of lens. We're going to pitch our TED on the types of lens. So we need to know what are the types of lens. We have the converging lens and we'll have the diverging lens. So we'll be looking at that this morning. We'll look at the lens formula, which is a bit similar, which is similar actually to your mirror formula, just that there are some variables we have to keep into play, right? When you're talking about the lens formula. After that, we'll look at the power of lens, right? We also have to consider the power of a lens and see what it entails. All right. So that said, let's get started. So now the first thing we're going to look at is just the concept, right? Just like we did yesterday. So refraction is simply the change in direction of the ray of light. It has to do with what? The change in direction of the ray of light when it travels from what? From one medium to another of different density. So I'm not going to spend much time there because we've done that yesterday. We saw what happens. What brought about refraction is difference in the what? The direction of the light, right? As it travels from one media to another. So now refraction through lenses also involves that same changes in direction of what? Of the rays of light. Okay. So based on the concept yesterday, also validates the refraction through lenses, the change in direction of what? Of light. Now, it is important to understand what a lens is. Every time we say lens, even in camera, we'll have the lens of a camera, right? So now, a lens is simply the portion of a transparent medium. It has to be transparent for light to be able to pass through. When we look at the rectilinear propagation of light, we said that there are three conditions that will happen for light to pass through an object, and one of those conditions happens to be that um, the material should be transparent, right? So unbounded by two spherical surfaces, right? Two spherical what? Surfaces. Sorry, mistake. Two spherical surfaces or by a plane, are you there now? And a spherical surface. So that means it can be a spherical surface just like the one we have here, or it can be bounded by a plane. This is the plane, right? And a spherical surface, just like you can see right here. So these are the two cases you can have that. Does that make sense? It can be bounded by a spherical surface, or it can be bounded by a plane and a spherical surface at the same time. Later, you're going to understand why these things differ the way they are based on what actually guides them. Okay, but the key point here is that it should be a transparent what? Medium. All right, so let's keep moving. Now, what are the types of converging lens? Sorry, types of lens is not types of converging lens. So this should be types of lens. So sorry about that error. So this is types of lens. Yeah, types of lenses. All right. So, and what are the different types of lens that we have? We have the converging lens and we have the diverging lens. But let's first of all consider what? Your converging lens. All right. So now, converging lens, these are thicker. They actually thicker at the middle. Are we there? They actually thicker at the middle than at the edges, right? So when you talk about converging lens, they are thicker at the middle than at the edges. You're going to look at a converging lens and see what the images look like. All right. Then another key point about your converging lens is that just like the name entails, converging, right? Just like the name entails, converging, meaning that it makes the light ray that is coming from a particular point to come together at a point which we call the principal focus. I'm glad we've treated mirrors. And when I treated mirrors, I explained a particular concept. And I said, for your concave mirror, it converges. It comes at a point, which is your principal focus. That's the same thing that happens with your what? With your converging lens. So the rays of the light that is coming from a particular point, they all come together at a point or converges at a point that we call the principal focus. And that's what brought about the name converging, meaning that the rays of light comes together at a point. Now, there are different kinds of converging lens. The first one is the biconvex. You can see the shape of the biconvex, looking more like a half moon, right? We have the piano convex, just a section of it. Is more like the moon, the different shapes of the moon, you know. Then we have the converging meniscus. You can see that there, right? So now these are the different examples of your what? Of your convex lens. The biconvex, piano convex, and then the convex meniscus. All right. So these are the different converging lens that we have. You might need to take note of the shapes, should in case there are diagrams that comes from there, you know. But on rare occasions, will you see that? But it's important that you just take notes. It's not a big deal, right? So that is this for your converging lens. Then the second guy is your what? Is your diverging lens. Remember what I said about this one? That these ones are thick at the middle than at the edges. The middle is thicker than the edges. That's for your converging lens. Now, but for your diverging lens, the middle is thinner than the edges, right? The other one is thicker. The middle is thicker, but for this one, the middle is thinner, right? Why the edges are thicker. You get the point now, right? So now, a diverging lens makes the rays of light passes through it to spread out. They diverge, just like your convex lens, your convex mirror. You know, in a convex mirror, it diverges. All right. So now, but the other guy will converge at the principal focus. And that is what your converging lens does. You get the point now. So that's why most times it becomes a little bit confusing about your concave mirror and your convex lens. Are you seeing that now? Concave mirror, convex lens. So when I have a concave mirror converges. And that's an example that now likened up to your what? Your convex lens, which means converging. So don't be confused. A convex lens converges, concave lens diverges, right? So now, but in the mirror, you have the concave coming together, the principal focus, the convex diverging, all right, spreading out as the rays of light enters it. Okay, so now let's look at the different parts of lens. The lens and the mirror is just the same thing in terms of the terms. We have what we call the principal axis, but what changes here is that your center of curvature, all right, becomes the optical center. Does that make sense? For the mirror, we call it what? For the mirror, it is called what? The center of curvature. But for the lenses, it is known as the what? The optical center. I hope that makes sense. All right. So now, what is the principal axis? It is not that line that joins the center of curvature of its surfaces. Let's look at the diagram so that it's going to make more sense to us. So now this is a converging lens, right? This is the image of a converging lens or the diagram of a converging lens. As always, that line that moves through them, through the center, is your principal axis. All right. Then this C, in the mirror, it was your center of curvature. But for your lenses, it is called the optical center. Now we have the principal focus, which is P. Then the distance between the center of curvature, which is the optical center at this point, from the principal focus is what you call the focal length. So that means that the distance between here to here, I mean, from this very place, all right, to this very place, that distance is your what? Your focal length. Does that make sense now? That is your focal length, distance between the center of curvature and the what? The principal focus. So it is still the same concept as your concave what and convex mirrors. If you are with me, can you give me a thumbs up? And if everything is making sense, hope is connecting, right? You are connecting the dots. Thank you, Paul. Right. Lillian, Confidence, and the rest. Hope you guys are following through. Nobody gave me a thumbs up aside. Okay, that was a thumbs up from Lillian. Okay. About Confidence, City, and others. Right. So that is just what the whole thing. City, are you following? All right, good. So I believe that that mirror stuff will be making sense now because we are trying to connect everything together, right? So now, that said, you could see the diagram and the structure. Now, I've defined the terms here that the principal focus is the point, right, at which all the rays parallel and close to the principal axis converges. So for the principal focus, for converging lens, it converges, all right, at the principal focus, but at the for concave lens, that's for diverging lens, I mean to say, it does what? It diverges. All right. So at that point, it does what? It diverges. So diverges for diverging lens, that's the principal focus. Those rays of light is going to diverge. Then we'll have the focal length. This is the distance between the optical center and the principal focus of the lens. Your mirror should give you an edge at this point in time regarding this very subject. Okay. I believe that each and every one of us is following and that everything is making sense to you. All right. So that based on that image, look at what I actually pinpointed here. If you observe something, this is the rays of light. So once the rays of light enters the mirror, it does what? It refracts. There's going to be a change of direction. So when it changes, it comes to this point, then as well here. So everything is coming to that focal principal focus. As they are converging, they are coming to the meeting. But if you observe, this is where the principal axis is, right? This is the principal focus of a converging lens is on the opposite side of the incident ray. This is the principal focus. This is where the incident ray is coming from. And the principal focus is on the other side. Why the incident ray is on the other side of the lenses. If you can observe that on the image. But for the diverging lens, you see what will happen. Diverging lens, they are on the same side. Both the incident ray and the principal focus are on the same side. And that is why they don't converge. That is why they end up what? Diverging. Okay. So look at that very image for your for that. Before then, look at the images formed, right? What are kind of images are formed for your convex lens? Just like in your concave mirror. Remember, for concave mirror, we have three forms of the images. The images at every point in time is going to be what? Convex mirror. Who can remember? You can on your mic and talk. For convex mirror, we had that no matter the position of the object, the image is coming from a convex mirror remains the same. And what is the nature of the images formed by a convex mirror? Anyone that wants to talk, you can unmute yourself and go ahead to talk, okay? Should I start calling names? Should I start calling names? All right. Confidence. What happens when the images, what kind of images form from a concave mirror? Convex mirror, I mean to say. Paul, what kind of image is formed? Lillian, what kind of image is formed? Titi, what kind of image is formed? All right, no one is talking. Does that mean that the last thing we did, you guys have actually forgotten everything? And that's quite bad. Who is talking?
So what's the question?
Oh my goodness. I said, what kind of image is formed by a convex mirror? We said something the last time that for a convex mirror, no matter the
The,
position of the
the
object,
image is
the image is
virtual.
what? The image is
Virtual.
virtual, okay? Okay.
Uh, it's diminished.
No,
For a
you are
convex,
looking at what I wrote. I'm talking
no,
about
not at
convex mirror.
no.
What will
See,
landing?
no, I already came about across it already. Not what you wrote though.
Okay. Okay,
Yeah,
diminished. Okay.
and it is upright, and the image is behind the mirror.
Behind the mirror. Okay, there's nothing like behind. Now, anytime I say convex mirror, what should come to your head is the Kekenapep. The mirror of a Kekenapep. Yes, the image is diminished. That means it's smaller than the object. And that's why they say objects in the mirror are closer than they appear. Right? They are upright. Certainly, because if it's not erect or upright, you cannot be able to do that. Then it is a virtual image. Okay. So these are the kind of things that we'll see from your convex mirror. So now, for for the convex lens, the same thing happens for convex lens. Convex lens, no matter the position of the object, the same kind of image is formed. And the image is going to be virtual. The image is going to be what? Upright, and it's going to be what? Diminished. That means it's going to be smaller than the object. So the images formed from a convex lens is fixed, no matter the position where the object is. Just like your convex mirror as well. Does that make sense? What happens in the convex mirror is exactly what happens in the concave the converging lens. Okay, no matter the position, the image stays the same, and it's going to be what? Virtual, upright, and diminished. Always use Kekenapep to remember what the form of the image is going to look like. Now, for your diverging lens, you could see how the diverging lens look like, right? It has that plane surface and then a spherical surface as well, right? Bounded by a plane surface and what? A spherical surface. Now, if you observe, as always, this is the center the optical center. This is the principal axis. But now observe what happens in the incident ray. The incident ray is coming from the left-hand side. The principal focus also is on the same side with the incident ray. But for the convergent lens, the case was different. For convergent lens, it was entering from this side, and the principal focus was on the other side of the mirror, of the lens. Okay. So, but for your divergent lens, what happens at this point is that it comes through from the same side, incident ray, and the principal focus is also on that same side. And that is why the rays of light end upwards, spreading out or diverging, as the case might be. Now, if you observe, this is the ray. When it hits the lenses, it does what? It diverges. All right. Then the same thing. It doesn't actually, it may look as if it passes through the principal focus, but it doesn't. And that's why the focus of a diverging lens is a virtual focus. All right. But the focus of a convergent lens is a real focus. All right. It's going to be a real focus. So it's very important for us to always, at every point in time, remember this. A virtual focus, I mean to say. Right. So I said something that the principal of a divergent lens is on the same side as the incident ray, and the rays do not actually what pass through it. Okay, it doesn't actually what pass through that very principal focus for your diverging lens. Now, for diverging lens, based on the position of the image, different position of the object, different kinds of images can be formed. So it's very key that you pay attention to the position where the object is placed, because it's going to affect the kind of image that will be formed, just like your concave mirror. What happened in concave mirror is that different position of the mirror determined the outcome or the result of the kind of image we are going to have. The first time we looked at when the object is at the center of curvature, when the image is at the principal focus. Sir, just want to be sure, a divergent lens, is it a concave? Now, for you to remember, what you search, what you see with your eyes, you can't forget. Can you quickly minimize? Go on Google and search that you just searched. Is divergent lens a concave lens? So that when you see it, it enters your eyes and you don't forget. Not what I said. You are laughing. Can you go and check it now? You have 2 seconds to do that, because sometimes it can be confusing as I'm saying it. Remember, I introduced the convex mirror. Convex mirror is a diverging mirror. But when it comes to the lenses, reverse is the case. So Rina, have you checked that? Check. Because if I keep you, still ask me again. But when you sit and read with your own 2 eyes, it is better that way. Have you done that? So I can proceed, please. It shouldn't take long. It's a question answer that comes in immediately when you search. So what do you have? What do you have? You can unmute yourself. Yes, it is. A divergent lens is a concave lens. Beautiful, right? So that is the same thing that we spoke about. Remember that it's more like a flip of it. In the convex mirror was what? Diverging. Are you there now? Convex mirror was diverging. Concave mirror was converging. Are you seeing it now? Was converging. But when it comes to mirror, the name are the same. When it is converging, it is a convex. When it is diverging, it is a concave lens. It is only mirror that it was switched. So I believe the way you've seen it now, you will remember it faster than when I'm saying it the way I'm saying it. Okay? All right. So that's for that. So you have your divergent lens, right? In your head, you can be saying concave lens. Okay? So now, so what are the images formed from a divergent lens? But for the sake of Lillian, I'll just be okay. Let me continue calling it divergent lens. All right. So the images are dependent on the position of the object. Now, if I extend my principal axis, so that you can get the context, if I extend my principal axis a little bit longer, sorry, that's not a good one. That's perfect, no? I hope others are following. This one is only Lillian that is asking question. I hope everyone is following. All right. Let's manage that line, okay? So now let's extend that line, but then it doesn't look good in my eyes, which I don't really like it. Yeah, this is better. So now for your principal axis, imagine we extend that line so that that very position here, the position here, becomes 2 times our principal focus, all right, or 2 times the focal length. So now the images, where you place that images matters sorry, where you place the object matters a lot. So now the first one is when you place the object beyond. Why are you giving me a thumbs up?
I know.
Eh? You are
Good.
you're okay. Okay,
Good.
okay. So now objects beyond 2f, right? When you have those objects beyond 2 times the focal length or 2 times the principal focus at the back, beyond that 2f I wrote there, the images is going to be what? Smaller. The image is real, it's going to be inverted, but it's going to be very, very what? Small. Beyond 2f. All right. That's why I actually brought this image here so that we can have a context of what I'm saying regarding your what? Your concave lens. All right. Your divergent lens per se. Okay. I don't want to be saying concave convex so that people don't get confused easily, right? So that's what I'm saying divergent lens. So that on your own, like you did, you cannot know whether it's concave or convex. All right. So now what that simply means, I wrote PS, all right? Far objects are smaller. So when the objects are very far from the mirror, sorry, from the lenses, what happens? When the object is very far from the lens, what happens is that what? The objects are what? Are smaller. All right. To also help some persons that will be watching the recording, remember, it was in concave mirror that the position mattered. Easy way to remember, Lydia. It was in concave mirror that the positions mattered. Anywhere you place the object determines the kind of image you are going to form. It is also in divergent lens that the image, the position of the object mattered. So therefore, that very place that the object, the position affects the outcome of the image is all about concave. Give me a thumbs up if this one is easier for you now. It's all about concave. Anytime the position matters for the object is about concave. Divergent lens position mattered. Concave mirror position mattered. All right. So that's it. All right. So now the next one is object at 2f. If the object is at 2 times the principal focus, which some persons will say 2 times the distance, which is the focal length. All right. 2 times your focal length. If the object at 2 times the focal length, what happens at that point? The image is still real, the image is still inverted, but this time around, the image is what? Same size. So observe this. When you are a bit far away from the mirror, and as you are coming closer, key variables are changing. And what is the variable that are changing? The outcome of the size. Far away from the lens, the image is smaller. I would have started drawing to show you how those rays are formed. Start drawing the different position where it is going to be, where the image will be formed. If you go to your physics textbooks, you're going to see those diagrams. But I feel it might be confusing at this point for you guys. So all you need to remember, when it is far from the lens, object is smaller. Image is still real, it's still inverted. When you are now at 2f, which is your what? Object at 2f, 2 times the principal focus, the image will now be same size. Now, the next portion, it is now when you are moving to the what? To the focus itself. 2 times the focus was the same size. You are now moving closer to the mirror. But upon moving closer, you stop at the principal focus. So the object between what? The f and 2f. Remember, we are drawing closer to the mirror, closer to the lens. So between f and 2f, what happens again is that the object gets what? It gets magnified. That means it gets what? Bigger. Have a bigger image. All right. Then finally, when it gets to f, which is the principal focus, the same thing that happened in your concave mirror. And what happened in the concave mirror is that the images is formed at what? At infinity. So at every point in time for a concave lens and a concave mirror, what happens is that what? The images are formed at infinity for the principal focus. All right. Now, but between, as you're coming closer, just see this way. I'm coming to your house. When I get to the first bus stop, the object is smaller. I move a little bit more, which is now at my 2f. All right. First time I move beyond 2f, what happens? It is smaller, isn't it? As I'm coming closer, At 12, I see that it is now the same size. I'm coming a little bit more closer, it is larger. Then when I get to the principal focus, what happens? It is infinity. It cannot be what seen, no image is seen on the screen. All right. Then the next portion of it, it is when you are now very close, extremely close to where? Extremely close to the lens. That means between what? F, distance less than F, which means you are now here, close to this place, very close to the mirror, right? Very close to the center, the optical center. When you move closer to the optical center, what happened is that the what? The image is now, what happened to the image? The image is what? Magnified. But it doesn't just end at being magnified. Something happens right there. I will listen in now. What happens right there is that the image is now what? Virtual. All right. Remember that at that very close point, it becomes what? The image is what? Is virtual, it is upright, and is magnified. So a lot of variable changes. Unlike the other variables where the image is real, the image is inverted for all the journey you have been making. As you move beyond 2F, as you moved at 2F, as you move between 2F and F, as you go to F, all of those guys, the variables about the image being real and inverted, we are all around here. But immediately you met at the principal focus that it turns to infinity, then as you move closer, what happens? The image becomes virtual, it becomes magnified, right? And also upright, no longer inverted. If you are following me to this point, can you give me a thumbs up, please? All right, it is following. Lilian is following. Okay, beautiful. So please, that's the concept. It is quite easy for you to recall if you study these things over and over again. But if you feel it's convenient for you to draw the rays, I don't think for exam you start drawing those rays. It's something that once you look at it, you should be able to recall it immediately. So that's the process, and that's what is. All right. So in simple terms, we have smaller, same size, large and real. Then the other one infinity. The other one will not be what? Large and virtual. Two same size, smaller, large and virtual, magnified and large, just that way. All right. So I believe that the concept is making sense, almost similar to what you have for your concave mirror. When we treated concave mirror, similar because they are all the same process. All right, right there. And I hope that it's making sense to us. Now, let's look at the lens formula. The lens formula is similar to the mirror formula, but you have to pay attention to the sign convention. In the lens formula, the convention matters a lot. You don't just assume anything you want to assume. The what do you call it? The signs are of key importance for the lens formula. So you don't go and solve lens the way you solve for mirror. You're going to fail woefully, right? And the answers might be in the option, and then you come outside of the hole and you are rejoicing, not knowing that you are rejoicing for wrong answers. All right. So what do you need to take note of? All distances measured from the optical center of the lens. All distances are measured from the optical center. The optical center is our reference point, which happens to be the center of curvature for your mirror. All right. Then number two, the distances of real image, object and foci are positive. When it comes to real image, it comes to the length, everything is going to be positive. Why that of virtual images, the object and the foci are going to be what? Negative, right? So that means the focal length of a virtual image is going to be negative, right? The next one about that is that the object distance is also going to be negative. Now, most importantly, like I said, the focal length of a convergent lens is positive. Focal length of a convergent lens is positive, while the focal length of a divergent lens is negative. So they might tell you, can you still hear me now? Can you give me a thumbs if you're still following? Good. Now, they might tell you that the focal length of a divergent lens is 15 over 5. It is you that will know that when you are solving that very question, you're going to write minus 15 over 5 because it is a divergent lens. And the value, the length of a divergent lens is going to be negative. Sometimes, after solving for the image distance, I will pay attention. After solving for the image distance, and it gives you a negative value, they will ask you, did I say give you or gives you? What did I just speak now, man? Please, hope I said give, or is it give I said? I don't think so. Was that what I said? Well, I'm teaching physics, not English. I hope you guys are following anyway. Oh my goodness. All right. So I was saying something in terms of, if assuming you solve a particular value and it gives you a negative image, right? The image this time becomes negative. They'll tell you what kind of image was formed, right? Because you solved and the image distance was a negative value. That gives you a clue that this guy is a what do you call it? Is a virtual image, because a virtual image is going to come up with a negative value. Is that okay? So take note of that. They might ask you what kind of image is formed. If the image distance is a positive value, it means that automatically that guy actually is a real image. So as always, I said as always, the image height over object height is equal to image distance over object distance, which is the formula for your what? Magnification. So nothing has changed in the magnification formula. Is that okay? In the magnification formula. So please, I want us to do something after the class, please. If you have your phone, please try to reach out to Ferami, right? After the class, I'll call her as well. But it will be fine if a good number of us from the boot camp put a call across to her, okay? She's not feeling fine, okay? But I want each and every one of us to reach out to her, okay? Yeah, please do well to reach out to her. Lillian, reach out to her. Confidence. Maybe I will. How do you guys get to know her number? Maybe I will just mention her on the group chat. Is it important to mention her? Just look for the number or send me a direct message and I'll forward the number to you, so that she doesn't get to know that we want to call her. Is that okay? A thumbs up if you're in support of what I said. A thumbs up if you're in support. Okay, Lillian, thank you. Susan, you're not in support. Susan, you're not in support. Justice, are you here? Justice, I also want you to give her a call as well. Right? Everyone, at most, good. Justice as well, please give her a call. Right? Not to be only the girls calling her, please give her a call. I myself, will also call her immediately after the session. Let's keep an eye on each other. Let's put a smile on her face this morning. Imagine how happy she's going to be. All right? Yeah. Then if you think you have a little thing on you, you can send her money for what? For fruits. What do you think? Yes, even if it's 1,000, I'm serious, please do that. That's why we are one family. Even if it's 1,000 naira, it's something. Even if it's 500 that you have, just ask her for her number and just ask this OP line, just send 500, 1,000. That's how you take care of those that are sick, not only praying for them. Okay. All right, so that's for that. And I believe you guys will do. If you're going to add something to that thing I said, can you just give me a thumbs up if you're going to add 500, 1,000 to what I just said? How many persons?
So we can add the money, but it's just like it feels small if you are sending it to her like 500 or 1,000. I feel
No, no,
like
it's
if
not.
all
It's
of
not.
us.
It's, no, send it individual. Okay, want us to send it together?
Yes.
Okay, we should send it together. If you're in support of sending together, give me a thumbs up. If you're in support of us sending together, give me a thumbs up. Okay. So after the class, please send me a direct message. I'll give you my account number and then we'll forward everything to her. Is that okay? As a team. Now, Titi, you want me to cover all of you up here? I just know what you guys did now. I know what you guys did now. So you now behave here and they'll be like, oh, now boot camp. It's entirely fine. All right. So let's go. I've said about the multiplication formula, and then we've looked at the power of the lens. So now for the power of the lens, we define the power of a lens as the reciprocal of the focal length expressed in meters. If the focal length is a meter, this is the formula, P is equal to 1 over F. I've seen a lot of questions under the power of a lens. All right, P is equal to 1 over F. Now, when the focal length is 1 meter, the power of the lens is 1. Who can pronounce that? I've tried to see how I can. Is it dipometer or dipo what? English guys, please. Justice and the rest. How do you pronounce that very well, dear? One word? Everybody's now locking up. So now when I want laugh, make I pronounce that. Anybody? Okay, nobody saying anything. So When the focal length is 1 meter, the power of the length is that thing you can see on the screen. Okay, one that thing you can see. All right. So that is why there is no. All of you are laughing, right? So 1 meter is equal to one of that unit, right? And that unit is not an SI unit anyway. But sometimes they can give you that the unit of the length in terms of one this thing. Okay. So take note when you sit in an exam that 1 meter is equal to what? One. All right. Good. So now, but if the focal length is in centimeter, remember that 1 cm, 1 meter is equal to 100 centimeter. If the focal length is in centimeter, all you need to do is to have this formula. What a blind man. What if a blind man that can't see it? Oh, that's true. So for a blind person, it's true. Imagine a blind person watching. Okay, let's not do that. Listen at the stuff for those with disability. Okay, now the power of the lens is 1 DIOBTRE. So 1 meter will give you 1 DIOBTRE in case the person cannot see. Thank you. So now we have that P is equal to 100 all over F in what? CM. If the F is in CM, just do 1 over the focal length. But remember that you are or just convert the centimeter to meter, then you do 1 over F. If you understood what I say, give me a thumbs up. Give me a thumbs up. So in whatever thing they gave you, if it's in centimeter, convert to meter. I know that 1 meter will give you Y, 1 dipole 3, I'll be dipole anything. All right. So note, very important, that the power of a converging lens is positive and the power of a divergent lens is negative. Sometimes after calculating the power, and they will be like, what kind of lens is this? Is it a convergent lens or a divergent lens? So if the power is positive, that tells you that that guy is a convergent lens. Just the same way that, remember, why will it be positive? Because the focal length of a convergent lens is positive. And if the focal length of a convergent lens is positive, that implies that the power of a convergent lens will be positive as well. And the power of a negative lens is going to be what? Negative. If you understood what I've been saying all this while, can you give me a thumbs up? If everything has been making sense, a thumbs up. Then I'm waiting for Paul to send the questions, but Paul is no longer online. Who else has access to the place that he normally gets those questions from? That person could save us the time and help us do that. Are we still following? Yeah, confidence you do. Okay. Quickly, let's solve questions on this so that I know I'm done with anything that has to do with your convex and concave mirrors. Okay. All right. So now, in summary of what I've done so far, right? Let's go again. We've looked at the types of lens, and we say we have converging lens, I have diverging lens. Are you getting the questions? Get the questions. We have converging lens, we have diverging lens. So for converging lens, we said that the center of the mirror is actually thicker. Center of the lens, I don't know why I keep saying mirror. Center of the lens is thicker than the edges. This one, diverging lens, center is thinner, right? For this one, position does not matter. Anywhere you place the object is going to return the same image. And the result of the image is going to be 1, an upright image, 2, a virtual image, 3, a diminished image. So these are the kind of images that will be formed from your lenses, okay? Then for divergent lens, the position matters. If it is beyond 2f, we say that it's going to be very small. Image will be real, it's going to be inverted, it's going to be very small. That's for beyond 2f. Then at 2f, we say something very interesting, that the image is still going to be real, the image is going to be inverted, but it's going to be what? The same size as the object. And then we said when the object is now between 2f and f, right? Between your 2 times the focal length and the focal length, we said at that point in time that the image, yes, is going to be what? Larger. But in as much as it's going to be larger, the image is still real and the image is still inverted. Now, we now said that when the object is now at the principal focus, f, that is going to be formed at infinity. So that image will not be caught on the screen. You can't see it. No image is on the screen. You don't see it on the screen, okay? Then finally, when the image is less than, at a point less than the principal focus or the focal length, which means closer to the center of the optical center, we say at that point in time, it's going to be what? Magnified. Not just magnified, very large, but at this point in time, the image is going to be erect, that is upright. but it's going to end up being a virtual image. We look at the lens formula and we say that it's important to know that for a virtual image, everything regarding that image is going to be negative. Both the object distance, the image distance is going to be negative, right? But if the image is a real image, that all those guys are going to be what's positive. Then we also say that for your focal length, that the focal length is going to have a negative value, that's for your divergent lens, and then a positive value for your convergent lens. Then for the power of a lens is simply 1 over f, and that 1 meter is equal to 1 dipole, right? So dipole 3 or dipole meter, I don't know again, all right? So, but that's the concept of the power of a lens. So always convert your focal length to meter before you can get the power of the lens. And we said that for a divergent lens, the power is negative, while for a convergent lens, the power is what? Positive. So have anyone sent any question to the chat so we can tackle it hands on? Anyone who has done that? I would have done that myself, but I prefer you guys getting those questions. All right. I prefer you guys getting these questions for some specific reasons. Anyone who has done that? Give me a thumbs up if anybody's doing that. Can I get a thumbs up? Can I get a thumbs up? Okay, confidence you are doing that. Please, let's be fast, please. Yeah, so I saw only 3 questions. Sister Confidence. Is that the only question you saw right there? Why not get more? Get more questions, okay? So we can get our hands dirty. Susan and the rest, assist her. Let's have more questions to tackle on this, please. All right, since we have, let's work with the ones we have already, and I wish Paul is in class. Paul delivers completely, right? I just wish that Paul is in class. He knows how to deliver like Hebrew women. All right. So now let's look at the first question. If you are still with me, give me a thumbs up. This is for short-sighted. I've not gotten to this point. We've not done things on optical instruments. It is tomorrow I'm going to do optical instruments. So when I do optical instruments, but I think I heard Mr. Kunle talking about short-sighted person yesterday when he treated eyes with you guys, the kind of lens they are going to use. I think he did that, isn't it? Yeah, I think I heard that. Overheard him saying it. I sure do overheard him saying that. All right. So now that will be for when you will do that tomorrow. So now a ray of light for a thin converging lens. In a ray diagram for a thin converging lens, a ray that is not parallel to the optic axis, a ray that is not parallel to the optic axis, but passes through the optical center, is not parallel to the optical axis. When they're talking about optical axis, they're talking about the principal axis, but passes through the optical center. We will do what? They say A, pass through undeviated. B, are we together now? B says pass through the center. Who is greeting me by this time? We're in class now. Passes through undeviated. B says passes through the center of curvature after refraction. C says emerge parallel to the what? Principal axis. And D says pass through the principal focus after refraction. So who is actually taking that one for us? Who? And when you answer, you give us your reasons for answering that. A ray diagram for thin convergent lens. The ray that is not parallel, remember, is not parallel, but it passes through the optical center. What will happen to it? Anyone? Should I start calling names? I should call names. Maybe I should call names. Titilola, what do you have to say about that? Titi, what do you have to say? Lillian, any idea? Any idea, Lillian? If you don't know, tell me you don't know. Don't keep calm. All right? Anybody? Confidence. Lillian, what do you have to say?
I think the answer is A. Passes through undeviated.
Passes through undeviated. Why is your answer A? Why did they pick A? Now, can we make reference to our image? You know, they said it's not parallel, but it passes through the optical center, right? So let's look at it. Can you mute yourself now, Lillian? All right. Now, this is what we have. And remember what I told you about the converging lens, right? We said that for a converging lens, that what happens? This is the point through which rays of light pass without being deviated by the lens. This is the point through which the rays of light pass through without being deviated. But can you see that statement here? Without being deviated. Is someone listening now? Without being deviated by the lens. Good. Look at that very statement. So now, when it passes through that point, but if you look at this, observe this. Observe these ones. Now, once the ray of light passes through that center, that through optical center, right? What happens? Even if, okay, let me go to that question again so I'll stay within the context, right? So that you don't just pick answers for picking sake, no matter how they do it. This is not what one. Let me quickly delete this. This should be in our next class so that it doesn't stay on this slide and people will get confused while watching the recording. We'll have no business with this one till we take things related to that. Then for this one, let me bring it up a bit. You are correct anyway, but then I want why it's going to pass through undeviated. Is that okay? But you are correct, okay? So a thumbs up to you. Yeah, so you should be proud of yourself actually. Now, a ray that is not parallel to the optics but passes through the what? Optical center, right? Because if it is parallel, what happens? It is going to be deviated. If you check that lens, it's going to be deviated if it's parallel, okay? So now look at it. Look at the ray. Parallel, it is parallel to the principal axis. And when it goes through, it's going to be deviated. But now, we have this optical center, and a clear definition I gave you about the optical center is that it is that very point where the rays of light can pass through without being deviated. So now the answer is what? It can pass through undeviated. Is that okay? All right. So thank you, Lillian, for that answer, which means you're following. Titi, are you in this class? Susan, are you in this class? Give me a thumbs up if you're following. Well, if Lillian is following, that's entirely fine. And she's answering questions as well. Okay. So the next one, I've answered this one. So the second one she sent, he said, an object is placed at 5.6 times 10 raised power minus 2 meter in front of a converging lens. Remember, for converging lens, the F is positive of focal length 1.0 times 10 raised power minus 1. The image is what? Remember, is placed at this in front of a converging lens of focal length this. Now, observe this. The image object distance, right? The object distance. Or do you want to try? Anybody that wants to try?
I think it's V.
It's going to be what?
V.
B. Is that what you said? You said, can you type it on the chat? The place you are is a bit noisy. D, okay? Virtual, erect, and diminished. Is that what you're taking? Okay, let's check. Now, the object distance, if you check, is equal to what? Is more like 0.0125612, yeah, 56 meter. That's the object distance. The focal length, right? Focal length is what? 0.1, because this is, yeah, 0.1 meter. So what will you see from this? What will you see from this? That object distance, that means if I have a length this way, I want us to really understand this. Let me just use length. I'm not going to draw the entire image, right? So let's assume that this is the center. Is someone following me at all? Give me a thumbs up if you are still with me. Good. Now, focal length here is 0.1 meter. Now, but the object distance is 0.056. Between 0.056 and 1 meter, which one is smaller? Between 0.1 meter and 0.056, which one is smaller? I want you to answer with that. Lillian, 0.56 is smaller. Beautiful. Now, what does that tell you? It means that if from here, please pay attention, my people. If this is the optical center, C, and this is the focal length, F, the distance from the principal focus, your focal length is from here to here, right? And that distance is what? Let's say 0.1. Now the object is placed at a point which is very close. They said 0.056. Now there's something I told you guys. When the object is placed less than the focal length, what happens? The image is usually what? Magnified, very large. Doesn't just end up being large, it is erect and is what? It is what? Virtual. Now, what did you pick? You said diminished. This is wrong, Lillian. Now, because if you check, it simply means that the object is placed less than. Look at what I wrote here. These things are quite interesting if you guys are following me. Look at this. There are conditions we gave. And one of the conditions is that object at distance less than f from the lens. So if it's less than f and it's closer, that means it is quite closer to the optical center, right? So this means for case, this simply implies the object y is closer, object is closer to the optical center. Object is closer to the optical center. And what happens here? Case of object less than the focal length. For the case of object less than focal length, what does it do for you? If it is less than the focal length, it simply means that the image will be what? Will be erect, that's upright, in bracket, upright, because Justice was a bit confused the other day regarding upright and erect. So it will be upright, right? It's going to be virtual, and it's going to be large. In brackets, magnified. Does that make sense now? Any more questions on that? So what does that tell you? That our answer here, the very correct answer we should go for, so this lens now is Z. Oh, they said converging lens, not diverging lens. Yeah. No, I don't think so. Sorry, this is a case of converging lens. This is converging lens, and I've been blowing grammar. Sorry. Lydia, you are following this lesson. You are in the spirit. You are really following this lesson. And I think we should give you a bottle of malt. Chilled one at that. Thank you so much. You are indeed following, okay? You are following. So people that are not following in the class is going to contribute for a chilled malt. Number one is Titi. She will be the one contributing that money. She's owing you a bottle of malt. Under my instruction and my command, Titi is going to buy Lillian a bottle of malt because she's not following while Lillian is following. All right? So now, Lillian, you are correct because no matter where the object is, so the key word here is that this is a what? This is a converging lens. So no matter the position of a converging lens, what happens is going to be virtual, it's going to be erect, and it's going to be diminished. That's a good one. And you didn't even take time to answer it. So no matter the position for converging lens, thank you, Lillian. For converging lens, no matter the position, all right, image is the same. And one is going to be what? Virtual. Two is going to be upright. That's erect. Then finally, it's going to be what? Diminished. All right, so that's it for that question. Did you send more questions, Confidence? Are there more questions to be tackled? Let me check. I can't connect since yesterday with my Google Meet. Someone is complaining that they can't connect with their Google Meet. I don't know what that problem can be. It's beyond me. Maybe they need to update. Aha, now you are coming up confidence. Now you are coming up with powerful questions. God bless you for that, okay? God bless you. Susan is going, see the way I'm sharing this thing. Since you are owing Lillian bottle of malt, Susan is owing confidence, bottle of malt, okay? See the way I'm sharing it. So I don't want to hear story. I don't want to hear him, okay? So once it's after the class, I want to see that distributed on the group chat. I want to see Lillian posting a picture. I want to see Lillian posting a picture of herself with the drink that you bought for her. All right. And I also want to see confidence with a bottle of the malt that Susan bought for her as well. All right. I think I've shared it accordingly. If you want someone to buy for you, be active in class, and I will share another person that will buy for you. Me no get shishi. Don't say that again. You receive shishi, okay? A powerful woman. So good. So have faith, okay? Have faith. Money is coming. Even if money is on. God, this call is recorded. Just look at what you are saying. 2 years from now, you come back to this call and see these things you said. That you don't have shishi, you don't have 100 naira. God, my goodness. Try. Well, you will have money soon, okay? All right. Besides, when I was in school, God, when I was in school, I think around my 200 level. Do you know that? Okay, I think 300 level, or 200 level in that range. I will eat in my house just to buy sachet water when they are selling it. I think 5 naira, be 10 naira. Yeah, I think it was 10 naira. I will leave my lodge and I will trek down to my friend's lodge to go and drink water. You eat in your own house, though. So life is funny. So we had experiences anyway. Lots of experiences. So it's a good one when you remember those experiences. So you remember today that there's a time you don't have 100 naira. Oh, I had nothing. Now you can share your story, okay? Now, distance between an object and its real image is 40 centimeter. Can you see that? Distance between an object and its real image in convex lens is 40 centimeter, right? If the magnification of the image is 3, calculate the focal length of the lens. All right. Always remember that the focal length of a convex lens is going to be a positive value. But I think you guys can solve this because it's connected to our Miro formula. So who is giving it a try? Anyone that wants to try it out? Do I have people in the house who wants to try it out? Give me a thumbs up if you are trying it out. A thumbs up if you are trying it out. Just a little expo, you are going to make use of this, the image height over object height at least. So you can get the object height, and when you do that, you could actually it accordingly. All right? Or you can make use of the image distance, you now get the object distance. Remember that image distance is V, object distance is U. So I think let's do that, okay? So that someone else can buy more for you now. This is the opportunity to do that. The distance between an object and its real image is 40 cm between an object and its real image, which is the object distance, isn't it? Then we're calculating the focal length. So you're fast. I didn't copy the formula. So you've not been writing all this while you're just moping at me. You guys don't copy notes. You guys are waiting for my slide. These students are quite lazy. So it's the normal formula we'll be using anyway. That's image distance over object distance. They've given us the object distance, right? Distance between the object and the image, right? They've given us the distance. So use the image distance, object distance. They gave us magnification as well. So when you apply that, you don't need this height anyway. You don't need this. You don't need this. So with this m and this, you get one of them, then you apply the formula and get your answer. It's just direct. Anyone solving that for us? You have 2 seconds to do that. Your time starts now. It's quite direct. So who is solving? If you are solving, give me a thumbs up. Susan, are you even solving out anything at all? Susan Grace Abraham. You see how I called your full name? Unmute yourself and answer me. Susan Grace Abraham.
Sir?
Are you solving anything at all? Hmm? Sir? I can't hear anything again. Oh. All I heard was, sir. Lillian, are you solving? Don't mind Susan, she's not solving anything. Titi, are you solving? $7.5. Good. So how did you get 7.5?
Yeah, let me now explain. So, we have the multiplication formula. So that's m is equals to image distance over object distance. So to get so I now did m is equals to v. What I did? Yes, v over u. So our v will be, since our multiplication is 3, so we'll get v is equals to 3u.
V equal to 3u. Go ahead. Go ahead, I'm listening. I'm listening now. Has NEPA taken the light? NEPA don't take light. I'm listening. Now, wow. Okay. TT of the entire series. All right, so look at this. They said the distance between an object and its real image in convex lens. Distance between the object and the real image, which entails that. Okay.
Sorry, it was my network that was more functioning. Okay. So as I was saying, our v will be equals to 3u because our multiplication is 3. So if you cross multiply, we get 3u. Then
okay, that means you are saying that m is what? Image distance, right?
Over yes.
Object distance. So yes. They said that v, they gave us 3 here, is equal to v all over u, right?
Yes.
So you said that v is equal to 3u.
Yes. Okay. So since they now said the distance between the object and its real image is 40 centimeters, that means the image distance plus the.
Okay. Go ahead.
Okay, sir.
Okay. Distance. Go ahead. Okay, I'm listening. So you said distance between
the object and the real image is 40 centimeters.
And the image equal to 40 centimeters. Okay.
So our object distance plus image distance will give us 40 centimeters. That's u plus v is equals to 40 centimeters.
Okay. So you said that v plus u equal 40 centimeters. Now, can you explain more so that they will understand? Can you explain more why you said that The distance between the object and the image is 40.
40 centimeter. Yeah, how do I explain now?
Actually, what is the image? First of all, what is the image distance? Can you give a context to what the image distance is? I'm coming, please. Water is rushing somewhere, so the entire house doesn't become River Niger. All right, Titi, continue. Okay.
Okay, sir. Sir, you asked the question, but I could not get
Yeah.
it.
So what is first of all, what is image distance?
Okay. Okay, so I think image distance is the distance between the mirror, which I think is object, and the image formed.
No, I'm confused. I think what you said. Now, why I'm saying this so that others will understand why I'm not saying that your addition is wrong, but I want you to give them a context to how do I know the one that is an image distance and the one that is an object distance?
Image distance is the distance between the mirror and the image formed.
Good. Then what is the object distance?
I think that one is now the distance between the mirror and the object.
And the image now. That's image. Okay, we're talking about object distance now. So now imagine that you have, let's say that the object is here. Let's say the object is here. All right. So let's say that it forms an image. I'm just drawing something that is off balance anyway. So now, are we following, guys? So distance from this mirror now to this place will be your what? Your image distance. Say this one is the image, right? So distance between the mirror, right, and your image is the image distance. And distance between your object and the mirror is your object distance. Now I'm trying to explain why she added. Now, distance between the object and the real image is 40. What it means that the entire distance from here through to this point is 40. Do you understand? Which means you are adding the distance from here to here and distance from here to here. Do you guys understand why she added both of them now? Give me a thumbs up if you understand what I said now. Do you understand why the distance was added? Lillian? Lillian? Do you now understand why the distance was added? Nobody's responding. I believe you guys understand why the distance was added. So, Titi, sorry. You can proceed.
So since we said V plus, that's image distance plus object distance is equals to 40. They'll substitute for what we got for the image distance, which is 3U. So instead of writing the V, write 3U plus U is equals to 40. Then we'll
3U
get
plus
4U.
What?
U is equals to 40.
Okay. So now,
and then
sub V equal to 3U into, let me call this equation 1, into equation 1. So now you now have that V is 3U plus U is equal 40. Go ahead.
Then 4U is equals to 40.
Then 4U is equal to 40. Proceed.
Our U will be equals to 40 over 4, and that will give us 10.
Okay, so this is 4. So U is equal to 10 centimeter, right? So what's the next step?
Yeah. So we are looking for our V now. Since our V equal to 3U, then we'll do 3 times 10.
No, but remember what we're looking for is the focal length, not V actually. So V will now be what? 3 times 10. So that V is equal to 30 cm.
So the formula for our focal length is 1 over F equals to 1 over V plus 1 over U.
Okay.
Then we'll now substitute for everything we've gotten inside the equation. That's 1 over f will
Okay.
give us 1 over 30 plus 1
Okay.
over 10.
Okay.
Then 1 over f will give us 4 over 30.
Okay. 1 over
And
f.
then
You said, sorry, you now said 1 over f will give us 1 over 30. Is that what you said? 1 over
4
40.
over 30. 4 over
Okay. 4
30.
over 30. Okay. So
Then if
that
we
f will
divide
now
it
be
by
what?
2, if we divide
If you
2 by
divide,
2, to give us 2 over 15.
so 1 over f equal to 2 over 15. Okay. Go ahead.
Then if we divide it with our calculator, we'll get 7.5.
Okay. You said 1 over.
Then we divide it with our calculator and get 7.15.
Okay. So 1 over f is equal to, yes, 7 points. You say 7 points what? 7
15.
point 7.15. Okay. So you have 7.15. All right. Thanks a lot. Then what's the next thing? Thank you so much.
That's all.
That's all. I
That's
disagree.
not
I
all.
disagree with
Oh.
you.
No, that's not all. That's not all. Sorry. Sorry.
So this will be over
1 over
1.
f will give
So
us
so you have 7.15 f
5
is
over 1. Then,
equal to 1.
mm-hmm.
Are you sure?
Yes.
So f will now be equal to what?
1 over 7.15.
Which will give us what?
Oh, I don't have calculator. Yeah, but let me try.
But is this 2 over 15? Okay.
Yes, sir.
Let me use my let me, I'm doubting you at this point. The one is the way you started going back.
No, no.
Okay, I talk 2 over 15 is 0.133. Don't worry, Lydia, I've seen the error
Oh,
already.
sorry. I might have skipped.
This is 0.133. All right. So now
Okay.
this will give us 0.133f is equal to 1. So
Yeah.
divide both side by 0.133, then all over 0.133. So that f is equal to what? 1 all over 1 over 0.133. So that will now give us 7.5 centimeter. All right, guys, hope you understand what we did. Okay, so that's how we can actually get the focal length. So for that very problem, we've calculated and we've seen that our final answer is going to be what? 7.5. Is that okay, guys? Is that okay, guys? Everybody? My mods is a lie. I'm not giving you any mods. You don't know what you are doing. You just divide 1 over 5 equal to 3.7.15. What do you mean by that? You should be the one giving me mods because you are stressing me. You should even give me the mods. What kind of calculation did you just do?
No, people are cheating in this class, but let's.
It's not about, but what I'm saying is a fact. We are not teaching you anything. Your calculation was off the radar. Be sincere.
No, oh no, I just skipped a step. Just
You
a
didn't skip
step.
it.
I was because I was
When
not
you go
sure
to the
my
exam
name.
hall, skip that same step. Whether no be 0, you go get.
I got the final answer, Sha.
Okay. You are doing well. Congratulations to you. All right, so let's go to the next one. All right, this one says the thin converging lens has a power of 4.0 diopters. Determine the focal length. Now, remember what I told us about. Someone should work this out. I explained about this power of a lens. I explained a lot of things about the power of a lens. Anyone trying it out? Anyone? So they said the power is this. What is the focal length? And remember that there's something I said before, right? That 1 diopter is equal to 1 meter. So go ahead and apply it. Someone should go ahead and apply that. So who is applying it? Anyone? Anyone? Give me a thumbs up if you are solving it. Can you give me a thumbs up if you are solving? Okay, Lillian is solving. Titi is solving as well. .25, okay? Another person that agrees? Do I have a supporting person for that answer? Lillian, what's your answer? Lillian, what's your answer? Susan, what's your answer? Confidence, what's your answer? Confidence said B. Okay. 0.25, okay? All right, so everybody's getting 0.25, okay? So remember that power equal 1 over F. And they have given you guys a conversion factor already. And that conversion factor is that one dipole meters is equal to 1 meter. So it's not a problem, unless they give us stats in centimeter or something. If the answer is in centimeter, then we'll have to do something about that. We'll first of all get meter and then convert centimeter. So now P is equal to 4, equal 1 over F. So 4F is equal to 1. Divide both side by 4. Divide both side by 4. So that F is equal to what? 0.25 centimeter. So well done, guys. Very correct. The answer is very easy, so you have no more for you, okay? And you're not the only one that answered it as well. So the next one says, if U is the object distance and V is the image distance, which of the following expressions gives the linear magnification produced by a convex lens of focal length F? Focal length, I mean focal length F. So what's the answer? See that derivation that Meso did that day. Similar to that derivation that Meso did that day. If you are solving, give me a thumbs up. If you are solving, give me a thumbs up. Nobody's solving. I should go ahead and solve. Should I go ahead and solve? Confidence said, I guess the answer is C. Are you guessing or are you solving? Who again? Titi, what's your answer? Okay. Titi says she thinks B. Okay. Good. So what are we saying? Sorry, C. Okay. So who wants to walk us through the solution? Anyone that wants to walk us through the solution? Anyone? All right, let's go. So I don't finish that food though. Am I eating? I'm not eating now. I'm not eating. We are solving question. How can I be eating? We are solving question anyway. All right. So we have that M equal to V over U, right? And then we have that 1 over F is equal to 1 over V plus 1 over U. I love Mesor's approach the other day. So she multiplied through by V. So we now have 1 over F multiplied by V is equal to, for a convex lens of focal length F, is equal to 1 over V times by V plus 1 over U multiplied by V. So that her approach that day was wonderful. So always maintain it. You see, they are repeating the same question. They asked that question for concave mirror. They are now asking it for a lens now. So V will cancel V. I will have that V over F is equal to V over U. But V over U is equal to M. So that means that, are we there? Is someone following me? If you're following, can you give me a thumbs up? Okay, good. So that means that M, all right, is equal to wait, multiply here by V. V over F equal to V over U. V over U is equal to M. So M equal to V over F. Linear multiplication. Okay. Minus F over F. V over F minus 1. Where is the minus 1 coming from again? Did I omit anything?
So I think, I'm not sure, but I think, there's 1 over V times V plus 1 over U times V. So that 1 over U times V will
Okay,
give us
one,
V
yeah.
one that is there.
Yeah. Bless you. I forgot that. This cancel this. I should have 1 remaining. Forgive me. Then plus 1 because 1 will still remain from this side. Forgive me. Yeah, boys are getting old. Boys are getting old. You wouldn't blame me. At my age, I'm still solving all of these things. Do you know how old I am? I'm an old man. Can't you see my gray hair? So now it's allowed. So V over U is M. So I know Lilia will not be looking at me somehow because she knows me more than any other person. She'll be like, look at this young man. What is she saying? Huh? So V over U, V over S is equal to V over U is M plus 1. Exactly. So that M equal to V over F minus 1. All right. All right. So we'll box this up again. Okay. So that's for that. So people that chose C, yeah, is very correct. Okay. So C is correct. And I think the first person that gave me that C is confidence. Okay. Now, Nikki Gold, you're on the call. Give me a thumbs up. If you're on the call, can you give me a thumbs up? Yeah. Yeah, that's a big Jane. Okay, now, so Nikki Gold, you are buying malt for confidence after the end of the class, right? Immediately after the end of the class, you're buying malt for confidence, okay? Why confidence is buying for Lillian, and Susan is buying for, who is Susan buying for? Can I remember? I can't remember again. I think Susan is buying for confidence or something. Yeah. Okay, yeah. Titi is buying for Lillian. Susan is buying for confidence. And you came late to class. Nobody's buying for you. All right. So that's for that. That question has been answered. So the next one, which we have here, is this one. Let me bring it up a bit. You came late just like Ananias and Sapphira. So the death of Ananias has happened already before you entered. So you don't know what is going on. You're not alone. No one is buying from you. Okay. Both of you can now buy for yourselves since we're not doing law feast. All right. So let's proceed. All right. By what factor will the size of an object placed 10 cm from a convex lens be increased if the image is seen on a screen placed 25 cm from the lens? So everybody now, see if you get this answer correct, if I begged you to buy somebody, then we nullify the drink. If you can get this answer correct, I'm talking about Nikki Gold, I'm talking about Titi, I'm talking about Susan. Anyone that gets the answer, first one to produce the answer correctly, and you are going to defend it, right? I'll cancel your debt. I'll cancel your debt. But if you fail it, I add more debt to it. All right, your time starts now. So should I send more questions? Are there more? Are there more? Yeah, fire us with more then. So I know I'm done with refraction through lens. Okay, send more then. I've copied the two that you sent. The last two you sent, I've copied it. So meanwhile, let me import that two that you sent of recent. Okay.
Sammy, I'm done. I'm done.
You're done.
Yes.
I doubt your speed. I'm doubting that speed. Are you sure I'm not copying that answer from anywhere?
No. The answer is just I just did.
I'm done too.
Let me see what
Man,
I
I already
got.
sent the answer.
No, you're not owing anybody anything now. Let me see my own first.
Oh yeah,
I was
send
the
your answer
first
to the
person
chat.
to send the answer. I was the first person to send the answer.
So let me explain how I got my answer.
No,
Oh
let
yeah,
me
relax.
explain.
I'm coming. Oh my god. You guys are very funny. So someone says she's not seeing my screen. Is that Big J? Yeah, Nikki, good. All right, let's see. Okay. So now Titi, you are still waiting for my screen. Someone have answered the question already. Why are you looking for my screen? So wait for the next question, okay? All right. So let's see. Titi, over to you now. And if you make any mistake in the calculation, it is cancelled. All right, go ahead. What will I do?
Okay, so I'm just going to do m is equals to v over u, and then we'll do 25 divided by 10, and the answer will be 2.5.
You said I will do what?
M is equals to v over u. M is the factor that will determine the size of the object. Then v over u, then we get 25 over 10, and the answer is 2.5.
Okay. No, this one is too cheap.
It's not, though. My debt has been cancelled.
By who? Who cancelled the debt?
That was the deal now.
No. I cancelled that deal. I didn't look at the question. It was a bit easy. All right. So now the next one.
About this.
The depth of I've told you are going to buy, you're owing somebody malt, isn't it? You're going to buy malt for someone that answered question. So
What happened? Why are you buying it?
because the person did well in class, the person answered question, you entered late. So anyone that actually answer the question correctly, I will call somebody that will buy malt for him or her.
I don't get money.
You are a business, something is in your mouth. All right. The next one, an object placed in front of a lens of focal length 10 centimeter. Calculate the distance of the image from the lens. All right. Very fast. This is also easy. Everybody send your answers. I will determine who to cancel the debt. All right. Everyone, very fast. They will have the next one. Find the position. Good. Now, this, okay, let me not say anything. Answer this one. Confidence, you sent more. Question Choco. Paul have sent 24 good questions. So who is solving that one? All right, very fast.
Sir, the answer is A.
The answer is what?
A, 30 centimeter.
The answer is A is 30 centimeter. Okay. Okay. Can you go ahead and explain your formula? You're the first to produce the answer.
So
go ahead.
We use 1 over F equals to 1 over V plus 1 over U. Then our 1 over F will be 1 over 10. Our 1 over V is what we are looking for, and plus 1 over 15. Then we'll carry the 1 over 15 to the other side.
Easy. I'm solving. Shut up. Easy. I say shut up. Forgive me. Sorry about that. What do you mean? Am I a human being? Am I a machine? Look at you. Are you rapping? Sorry, that was a reflex action. I said shut up. Oh my god. Go ahead. Titi, you know you're wicked. Hope you know you're wicked. Okay, because you said you should produce the answer. You want to kill me now. 1 over 10. How will I be solving that? Huh? Go ahead. 1 over 10.
Where did I stop? 1 over 10. Okay.
Equal to what?
1 over 10 minus 1 over 15.
No. We're here to place in the values now. We're looking for the image distance, which is 1 over V.
Yes,
right?
I said
so
1 over
F
will give us 1 over V plus 1 over U. Then our 1 over F will be 1 over 10.
Okay.
And
so
then
what will it be now?
Sir?
What will it be after subtracting? After subtracting, what's the value? Fast.
Okay, the value will be 5 over 15 equals to 1 over V. Then if we solve for V, we'll get... Sir?
Go ahead.
So if you are solving for V, we'll get 5V is equals to 150. Then V is equals to 150 divided by 5.
Excuse me. Where is 150 coming from?
If we bring the 1 over 10, if we bring the 1 over 15 to the 1 over 10, so that is 1 over 10 minus 1 over 15. Then if you are finding the LCM, we get 150. Then 10 in 150 will give us
1 over 10 minus 1 over 15 is what?
1 over 10 minus 1 over 15 is 5 over 150.
Okay, 5 over 150. That means you're not looking at my screen. I wrote 1 over 5. 1 over 5 over 15. Don't worry. So now V will now be equal to what? 150 all over 5. So that V is equal to 30 centimeters. Okay, that's correct. All right. So now look at the next one. These are quite direct questions. All right. So this is the next one. All right. So the next one says, look at this one. Now I will hold you people here. In this very question, they said, find the position and nature of the image. They said this is a divergent meniscus, right? So which means a divergent lens. Okay. So you should find the position now and the nature of the image. Not just the position, but the nature of the image. So now I want to see the person that will produce the answer for us. Why I import more questions. And please, all these questions on the chat, you can try solving them. There are a lot of them. Titi, please, where did you get 5? Okay, look at how she got 5. Okay, now,
sir, please, can we quickly check the question so we can write out the parameters we have?
Yeah, I'm coming so that I'll explain to Susan. Susan, look at it. Use calculator and do 1/10 minus 1/15, or you can use equivalent fraction. Is that okay?
Yes, sir.
Yeah.
So
So
you
just do
said
that. I said what, Susan?
you
Sorry.
said
How did you get 5? Well, come to think of it, when you subtract, is that what you got? 1/15. Susan, Titi, I'm not even checking your work. One
so
man over 10.
I don't understand. Where did she get 5? That's it. That's what I'm saying. Where did she get 5?
Sir,
Okay.
can
She
I
used
explain to
LCM.
her?
She used
Okay.
LCM. She used LCM. Yeah, she used LCM. She used LCM. Okay. She
Okay.
used LCM. Yes. So look at what she did there. She used LCM. So what she did there, when you're adding a fraction together now, you have this LCM of 10 and 15 is 150. So 150 will be here. So 150 divided by 10 is what? Is 15, right? So you're going to have
Okay.
15 times 1 is 15 minus 150 divided, that will give you 10. So when you subtract, you now have 5/150. Is that okay? But if you use your calculator, it's going to give you, if you use calculator, it's give you 1/30 directly. All right, this is the parameter for this one. Yeah. So there are more questions in the pipeline here. Please go on the charts and look at the questions, but they are still the same thing, okay? The questions are still the same. I'm just trying to pick the ones that might be a bit technical, so I can simplify them for you guys. So you see the same thing. Yeah, so still the same thing. So confidence sent more. So who is solving?
So I'm trying to solve.
Okay, Titi is solving. Susan is solving. Okay.
Sorry, sir, the question. I want to pick my answer.
Oh, yeah, okay. You're using the question.
Yes.
Okay, I have to check my schedule or something. But it's fine. All right. Hosanna just posted on the group chat. He said, God, I beg you. Joke aside, I just see my mock score now. Can you guys hear me? Hosanna, just keep solving. He has not been serious with classes now. Yeah, send your answers. I'm waiting. I will solve 3 more questions, and then we'll call it a wrap for the day.
Sammy, I have something to say.
Yeah, go ahead, Titi.
When I solved, I don't get any of these answers. But I know it is virtual, but I don't get any of these answers.
Okay, so why is your answers not the same as theirs? What do you do? Did you did anything, or did you say particular steps you actually took that was actually wrong? Check that. Check your work again. You know what you are looking for. You have the object distance. You know you have the object distance already. Object distance is 16 centimeter, right? You have the focal length, which is 20, but it's diverging. The focal length of a divergent lens is a negative value.
Yes, I did that, and I'm still not getting the
So
answer they got.
You did 1 over minus 1 over 20.
Yes.
Lillian, do you have a different answer for what she has before I start solving? Confidence, you have it. Sorry.
80 centimeter.
80. Okay. Lillian, do you have a different answer from what she has? You have the same answer from what she has.
Okay, since no one is 80 centimeter.
You got 80?
Yes.
Is that the same thing you got, Lillian? All right. Now, first off, we'll have that there's a statement I want you all to look at before I proceed. Very important regarding that our formula. I want you all to look at it. All right. So what did we say? We said that all distance are measured from the optical center of the lens. Distances of real image, objects, and foci are positive, while those of virtual images, objects, and foci are negative. Did you hear that? Distances of real image, objects, and foci are positive, while those of virtual images, objects, and foci are negative. So I'm going to make use of that very statement to solve what we are solve. We know that because that object is 16 meters away from the divergent lens, focal length is 20. It means that the object is closer to the center of curvature at the optical center, which entails that the image that will be formed is going to be a virtual image. So it is expected that my V will be a negative value. Do you understand? So now, if I have that 1 over F is equal to 1 over V minus negative 1 over U. Now, the object is 16 meters away from a divergent lens. So I have this is 1 over minus 20, or minus 1 over 20 actually, is equal to, it is expected that the image is going to be a virtual image. All right. So that will be what? 1 over v minus the object is 16 meters away, so we're expecting 1 over 16. All right, so that minus 1 over 20 plus 1 over 16 is equal to 1 over v. All right, so now I will apply my equivalent fractions. What will I multiply to 16? Is there anything that can be done, or can I use my calculator straight up? This is something as saying 1 over 16 minus 1 over 20 is equal to 1 over v. All right, so I'm thinking if there's a number I can multiply through, but let me just use our calculator. Okay, so 1 over 16 minus 1 over 20. All right, that will give us 0. That's 1 over 80. All right, I think there's an error somewhere. But remember that it is expected. There's something else I want to do now. If I have this negative here, multiply through by negative here, I'm going to have 1 over 20. I should have 1 over 20. I'm coming. There's something I need to put into account for 1 over 16. What could be the problem at this point? 77.63 centimeter virtual. So I think say now for evening B class. Yes, evening 9 be your own class. All right, evening 9 be your own class. Okay, that's Maotida. Okay, evening is your class by 7 p.m. So check your timetable for the SSE bootcamp. Is that okay? Give me a thumbs up if you heard what I said. So now, guys, pay attention to this now. We are running into a crisis here because of the changes in our value, right? Or you see that they neglected that sign. Okay, let's see if we even neglect that sign. What happens if we tend to neglect that sign that I just imputed now? This is a problem. Let me revert back on this question to see what we are getting wrongly, right? I need to revert on this. Let's see what we are getting wrongly, because I'm still getting the same thing you guys are getting, which is saying that thing is centimeter, isn't it? That's the same thing everybody has. Give me a thumbs up, right? A thumbs up if you have that same value, 80. So there will be a problem somewhere, which I need to rectify that problem right away. Okay, I need to rectify that problem. Yeah, so let's rectify it, please. There'll be a problem somewhere. Yeah, a very huge problem somewhere. I'm coming. Not really huge. Maybe there's something I'm not getting correctly. I think there's a concept I might be missing out. There's a specific concept I might be missing out. I personally might be missing out. So an object is 16 meters away from a diverging length of focal length 20 centimeter. So diverging lengths are known to be negative. 1 over v, 1 over u. Okay. Wait, am I using the wrong? I think I'm using the. This should be plus sign, isn't it? I think I'm using the wrong formula now. This should be plus here, please. Did you see what is happening here? Nobody is seeing this. The formula is 1 over v equal to 1 over v plus 1 over u. Is that not the formula?
Yes, sir. But even if you do it like that, it's still the same answer we get.
Okay. Relax. Let's check. Now. So that when I move it up the other way, I'll have a minus sign here, right? So minus 120 minus 1 over 16, negative sign multiplied through. So let me punch. So why is the values not tallying? Men and brethren, what could be the problem? Yeah, it's really going to be the same thing as well, because minus is still minus. It's going to be minus 180, 1 over 80. But they said that the answer is 76 and the rest of them. So there's something we need to pay attention. There's something we're not getting correctly. There's something we're not getting correctly. Let me check your textbook. What happens with the focal length? Let me check. I'm coming. 2 sec. There must be a way out of that 4 cm from a divergent lens of focal length. 1 over v plus 1 over v equal 1 over f. 1 over v plus 1 over 4 minus 12 minus 4 over 12. I think it's from their end. Guys, can you hear me? Can you hear me? I think it's from their end. Yeah, we are doing the right thing right away. Yeah, from what I'm seeing here, a similar question. For an object, 40 cm, yeah, 40 cm from a divergent, yeah. So it's from their end, okay? The correct answer is 80, right? 80, right? Okay, thanks, Mr. Hilary. Yeah, so it's from their own end, okay? So now, this will give us, when I simplify further, I will have negative 1 over 80 is equal to 1 over v, right? So that means that v is equal to what? Negative what? 80 centimeter. What does this negative imply? It means that it's a virtual image, right? Do you understand now? So virtual image, negative for divergent lens is negative, all right? So that means that our final answer, thank you so much for that verification, yeah. So I think that option, the options are wrong. So we are on point, is equal to 80. So, and it's going to be virtual. A thumbs up, everyone. So we've cleared that, isn't it? Have you cleared that now? All right. Thanks a lot. Okay. That said, let's go to the next question. I think we've solved everything, isn't it? Yes, I think we have. Then let me import. There are 2 more questions that she sent to us. Then I've still. Will you guys even pay me for these extra times? All these things I'm doing, huh? Somebody will not say my reward is in heaven. I know one of you want to say that now.
Oh, God will bless you.
Also. All right, so 15 cm, calculate the distance of the image from the lens. I think we've solved that already. An object 16 meters away. We've solved that already. Okay, so front of the lens, in front of the lens, behind the lens. The image is virtual. All right. All right, so let me import this last one so that we can call it a day, okay? All right, so just solve this one. Remember that this one now is simply that they change the distance. They change the distance at every point in time. I'm always giving you guys 2 hours, even if you don't start at the time we should start. All right, so look at that question. Remember that this one is in centimeter now. So let's see who will get this one correctly, and then we'll call it a day, everyone. All right, so just get your hands dirty and let's see what your answer is going to be. Yeah, get your hands dirty, guys. Get your hands dirty, guys. Get your hands dirty, guys. Meanwhile, anyone that gets this one correctly, I'll give that person a double salute. All right? I will give you a double salute. All right. Anyone that gets this correctly will receive a double salute from me. Yeah. Double salute. Mr. You came right on time. Okay. Welcome. So I'll give that person a double salute. I will give that person a double salute. Titi said D. Okay. Titi Lola said D. Who again? Do I have another option in the chat? Another person? But I think Titi said D. Yeah, Titi said D. Titi said the answer is a D. Is there anything that, let me stop, please. It's taking long. It's almost to 1. I have a meeting at 12:30 and it has passed already. So let's see whether it is correct. Find the magnification of image formed by a lens of power 0.2 when the object is 26 centimeter away from it. All right. Remember that M. Oh boy.
Sir, sorry, sir.
Okay.
The answer is 0.25. That's D. I wrote B by mistake. Sorry, sir.
Okay, D. Okay.
Yes.
You wrote D now. D was what you typed now.
It was B.
All
It
right.
was B and C.
Okay.
Okay, sorry,
B 0.5.
sorry, sir, it's D.
Now, wow. Organic. Kilo shekilo lukore. 1B. So you have that M is equal to V over U, right? But then power is equal to what? 1 over F. Now, the object is 20 centimeters away from it. So it means that U is equal to 25. But since the dipole is 0.2, remember this one is centimeter, right? So now power is 0.2 is equal to 1 over, I'm still looking for my F, all right? So I'll have that 0.2 F equal 1. So divide both sides by 0.2. So when I divide both sides by 0.2, 1 over 0.2 cross over to the other side is more like 2 times 10 raised to the power minus 1, right? But let's just, yeah,
5.
yeah. I can't hear you. So it's something as saying that, what did you say?
I said the answer is 5.
5, okay. So it's something as saying 1 times 2 times 10 raised to the power minus 1. All right. So F equal to, you said it's 5, right? That is 5. That is 5 meters. Are you aware? Are you aware it's going to be a meter? Well, let me cross check dividing this. Yeah, 5 meters. Because remember that why I did that is because remember that 1 meter will give us one dipole, right? Why dipole? What's the name again? Dipole tree, right? So now I've converted. Then converting this 5 meter now, it simply means that F is equal to what? 500 centimeter. 5 times 100. All right. So I now have that 1 over V is equal to 1 over F, I mean to say, plus 1 over U. Now, the value of my 1 over F, U is 25. I'm looking for the magnification, isn't it? All right. So this is 1 over 500 is equal to 1 over V plus U is 1 over what? 25. All right. So now when I simplify further, I have that 1 over V will be equal to 1 over 500 minus 1 over 25. So that's 1 over 500. I will follow in minus 1 over 25. That value is, why is it giving me a negative value? From a length of power, this 1 meter, 1 times 2, F is 5 times 100, that's 500 centimeter, because this is 0.2. All right. So now I have 1 over 500 is equal to 1 over V plus 1 over U. U is 25. So when I subtract, good, that will give me around 0.038. But I know that the magnification or why not move through straight up from here? Since I have my F already, can we move through? Yes, let's move through. Let's multiply through by V using that formula we had before, that M is V over F minus 1. Yeah, let's use that. M is V over F minus 1. Remember that M equal to V over F minus 1. Who can remember this formula? That's your multiplication formula. All right, good. So now, but I don't know my V now, so I need to continue. So now, 1 over V, all right, 1 over V will be equal to 1 over 500 minus 1 over 25. That will give me equal to minus 19 over 500. Yeah, good. So that V is equal to minus 500 over 19. That is telling us that is a virtual image, isn't it? That's what it's telling us. Then we have that M is equal to F over V minus 1. So that M is equal to what? 5 over, you don't have to use that negative sign. That negative sign is just telling you that it's a virtual image, okay? So it's equal to 5 over 19 divided by 500 minus 1. So that will give us that M is equal to 5 over 19 times by 500 all over 1 minus 1. Sorry, if you invert, this should come up. This should be 1 over 500. So that M is equal to 1 over 19 minus 1 over 1. So what will it give us? Is my answer in the option at all? Maybe I'm solving Japanese. So I have 0. Or even if I use my negative value, I'll have minus 1 over 19 over 1 multiplication V equal to this. All right. Oh boy. This question has opened Nigeria movie for me. All right. So I have, let me cross check. 1 meter is 1 dipole. Right. So 0.2 equal to 1 over F. Then 0.2, 0.2. I have 1 over 2, 0.2. 1 by this is 5 meter. Yes. But we need to convert meter to centimeter. I have to multiply by 100. It's you that got 0.25. How did you get 0.25? Even you, Lillian, what did you guys do? That me, I cannot get again. I don't have a smart teacher. Eh? So view about what did you guys do in particular?
Samuel, confess.
Okay.
You see that place that you changed when you got I think 5 as the answer for the F. I forgot to convert it to centimeter. I feel like that's
you didn't convert centimeter.
Yes.
You just used 5 that way.
Yes. I don't know if that's what
the object, unless are they leaving the answer, unless they are leaving the answer in centimeter per se, all right, or converting the other one to meter. Okay, if we are to do that, 25 divided by, why I'm converting is because this guy is in centimeter, our U, unless we convert the U to meter, which will be what, 25 divided by what, which should give us the same answer, 25 divided by 100. That will give me a 0.25. Which means my U at this point here is going to be what? Okay, let's do that way. It's going to be the same thing as well. So 1 over V, I'm coming to check what the problem is with that question. So now 1 over V, I have 1 over V is equal to what? Okay, I think I've seen where the problem is coming from. That formula is plus, not minus. Sorry. Did you see the error now? These students you guys are not really following me. By now, someone should have spotted this error. The formula is 1 over V, okay? When you now cross over, let me write this thing again. 1 over V is equal to 1 over V plus 1 over U, right? So when I cross over, okay, see the same thing. So I have 1,500 minus 1 over 25. So let me apply your stuff that you did. So I have 1 over V, right, minus 1 over U. So you guys didn't convert. That gave us 1 over 5 minus 1 over 0.25. So that 1 over V will be equal to what? So I have 1 over 5 minus 1 over 0.25. That will give us the same thing. All right, that will give me minus 19 over 5. Still the same thing. So minus 19 over 5. I know what I'm talking about. So this is V over 1, 5V minus V. So that will now give us what? 5 all over 19. Minus 5 over 19. Then applying our formula for multiplication that Mesa derived that very day, that M is equal to V over F minus 1. Or let's use M equal to V over U. So that the M is equal to, my V now is what? Is 5 over 19 divided by our U will give me what? 0.25. So I have 0.25 right here. So that M is equal to 5 over 19 times 1 over 0.25. So that my multiplication F will be 5 over 19 multiplied by 1 over 0.25. I have 1.05. Do we have anything like that in the option? Do we? It is not in the option. I might need to get back on this. But that's that's what I will solve in the exam. We might need to come back to this question, right? But this plus 0.2, is there a particular meaning that this plus 0.2 is trying to tell us that we don't know? Then you guys are saying 0.25. I'm still suspecting those that said 0.25.
So I didn't get the this the
I didn't get
confession.
what?
You didn't get my confession. I didn't change any of
you use 5
I used
directly.
25. I used 5 and I used 25. I didn't use 0.25.
Okay, you didn't convert. So but then if we fail to convert, that means we are not making. Is that okay? Now, from what we read here, unless they want us to go there, one, I don't stay here, one don't knock. Which kind of class we this today? So now look at this. So I need to finalize it actually. I'm using our stuff here based on 1 meter will give us 1 dipole, and they say that thing is 25 centimeter. Do you get the point now? If that thing is 25 centimeter, unless they want to write 25 meter there, that is the only thing that will make that answer be correct in what you did. But as long as what you have there is 25 centimeter, right? We need to convert. The U is 25. So where else can we take this question to? F equal to 1 over P. Yes. Yes. Wait. Am I making a mistake here? P is equal to 1 over F. The dipole is 0.2. This is F, right? Yeah, we are correct now. We are actually. I'm gonna take this question anyway. I'm correct. I will prove it even in court. See, and I'm serious about this. This call is recorded. So these options are wrong. These options are wrong. My other phone is off. We would have gone to, someone should go to any AI at all. Let's prove it on this call, please. That their option is, there is what?
AI says is D.
Is the, what did they do? Did they convert?
Let me even go through that stuff.
Yeah, go through. Let me see.
It says he first of all did F equals to, no, P equals to 100 over F.
Oh, 100 over
And
F, yes.
yes, that means F equals to 100 all over 0.2 equals to 500 centimeter.
Beautiful. Now, 500 centimeter, continue.
And then he did F equals to 100 over 20 and got 5 cm. For the, says
100
using the
over
likely
20.
intended value plus 20D.
Using what?
The likely intended value plus 20D.
What do you mean by a likely intended value?
I don't know.
See,
That's the question.
Can you share your screen?
The question. Okay.
Share your screen. Share your screen.
Okay.
See, can you, if they prompt it again, ask it, just share your screen. I'll tell you what to tell it. I have a paid version of it, but then my phone is off. I think that would have been more accurate. The F should be 5 meters. Yes, the F is 5 meters. But what we need to convert is because of this very statement here. All right. Calculate magnification. Okay. Scroll down. Can you go up? Good. Based on the provided option, there is likely a typo in the question. It was likely, Mona, give me thumbs up, Jare. So that question, that thing is, the options are wrong. There's nothing you will tell me. You get the point now. That option is very wrong. So now, if we are to solve this question, I can solve in 2 ways. Are we together, guys? Are you seeing what, did you see what it said there now? Using the value written as this, 0.2D. So there should be, there's an error there. Stop sharing your screen, okay? Yeah, I've seen what I need. I've seen what I need. So, Mel and Brethren, are you guys on the call now? If I did this exam, I go mad. But I'm very sure of what I'm doing. You get the point? Because when you are converting some of these things, you see the option is quite wrong. Okay, is that the option is wrong, or they made a mistake in this 0.2? You get the point now. That plus 0.2. Two things are involved. If you go 0.25 without converting your 25 centimeter, it means that either that guy is 25 meter, not 25 centimeter. Do you get my point? Do you understand what I'm saying, guys? Good. Because of what? 1 meter. Pay attention now. I need to go. 1 meter is equal to one dipotry. Nobody agreed to pronounce this thing for me in this class. So 1 meter is equal to this. All right. So therefore, after solving, I have that my F is 5 meter. But two things are involved. I can't be using meter and centimeter in the same question. Right? Are we together now? I can't be using meter and centimeter in the same question. If they gave me that my U is 25 cm, it's either I convert U to meter or I convert what do you call it? Either I convert V to meter or U to meter, or I convert my F to meter. Anyone you want to do. Okay. So now I converted the F to centimeter so that with the U will also be in centimeter. And after doing that, and remember there's a formula I gave us here. If the answer is in centimeter, if you want the answer to be in centimeter, you use that P is equal to what? 100 over F in cm. Use this formula, right? Okay, so Titi is very funny. So let me continue, please. Let me solve the correct thing, okay? So now when you do that, 1 over V minus 1 over 19. So V is equal to minus this. Remember that this sign here is telling you is a virtual image, right? Negative implies virtual image. Implies this is a virtual image. All right. So now let me bracket this since I have my V. So let me not stress us with this V over F. Or use the one you know, right? Use that M over V, but they will give you the same answer, yeah? So, but remember that M is equal to what? V over U. So M is equal to, don't use that minus, just carry out this thing over 19, because that sign simply means that it is a virtual image divided by U. The value of U is 25. So this is 25. So that M is equal to I will have 500 over 19 multiplied by 1 over 25. Sorry, yes, 1 over 25 because I've converted. So that M is equal to, let me punch my calc, then we are good to go. 500 all over 19 times 1 over 25. So this will give us that M is equal to 1.05. So that's the multiplication I got right there. Because U is this, I've converted my V to 500 over 19. So divided by U, so multiply. So that's what you're going to get, guys. Any way you want to do it. If you still want to follow this pattern of converting, okay, look at what I did here now. I converted C, U to V, to meter. So that in meter, we'll have minus 5 over 19, the same thing. So let's go ahead and find our final answer. So V is equal to what? 5 over 19 actually, right? Minus, that minus is telling you that is a virtual image. So now let's now look for this. So I have 5 over 19 times 5 over 19 multiplied by 1 over 0.25. That will still give us the same thing, 1.05. So anything you want to do in both ways, I've proved you that it is correct, right? This one is using centimeter, using meter. All right. So all the best, guys. Thank you for this Nigerian. Oh, that wants to play around with my head on a class that is recorded. Before they say, "Oh, this guy they teach these children." Oh boy, that's a good one today, man. So it's good to know what you know, okay? So that the options will not confuse you, even when you know what you are doing, okay? So I think the error is probably from them, right? They mean 0.2 or they mean to convert anyone. All right, guys. So I wish you the very best. There are more questions on the chat, a good number of them on the chat. So do well to get your hands dirty. And by tomorrow afternoon, I think you have chemistry tomorrow morning. So tomorrow afternoon, come to class. I will handle optical instruments. Under optical instruments is where you get to learn about myopia, hypermyopia, accommodation, all those challenges with the eyes, the eye defects, and the equipment you use to correct them. That is where you also learn about, are we together? You also learn things on optical instruments. You learn about compound microscope, all right? You learn about the simple microscope, learn about compound microscope. You learn about Galilean telescope. We'll learn about terrestrial telescope. We'll learn about the prism binoculars. We'll learn about the side projector, all right? We'll now look about eye defect and corrections, myopia, hypermyopia, accommodation, and the rest of them, right? The good thing is I'm using your textbook. That's the good thing. And that's why it looks as good as anything I teach. If you check the past question, the same thing. I'm using textbook. You guys, I'm reading as well, all right? I read. I don't know. I'm writing this jump with you guys. Yeah, I read anything you're seeing here is from your senior secondary school physics. All right, the informations, just arranging them better and picking the key informations that you need. All right, so what's the solution in the exam hall? What should we choose now? Sometimes they give bonus, so you can pick that 0.25. Assume that, see, if I'm in the exam hall, do you know what I will assume? I will assume that 25 is a meter, and I will not convert anything. I will use them like that. It's either I use that 5 meter, I just not convert anything, you get, and then I run through. That's what I would do. Just like what it did. No conversion. Assume that both of them are a meter. That's exactly a meter. I'll just go your way, all right? So you can have your 0.25. Okay, so all the best, guys. This is 101. I have a class at 1:30. So I will see you guys tomorrow in the afternoon. Yeah, we'll have to survive anyway. This class should be over 3 hours, I think. 2 hours, 30 minutes. I think so. It's 3 hours, which is 2 hours, 30 minutes. All right, guys. All the best. For those that watch the recording, people like mess or go hear them. All right. All the best, guys. Mr. Hillary, you can hear the recording. Thank you. Yeah, thanks for the love emoji. Thank you. I appreciate.